Hey coders, welcome back to the channel. Today we are diving into a classic binary tree problem from LeetCode. Find the bottom left tree value. It might sound simple, but trust me, it tests your understanding of tree traversal in a really interesting way. We will break down the problem, work through the logic, and then code up the solution step by step using both BFS and DFS approaches, so you are really fully prepared. So whether you are preparing for your next tech interview or just level upping your DSC game, this one's for you. So now let's get it started. So guys, let's start to solve a 513 question by the name of find bottom left tree value. So let's start to solve this question, and it's a 513 question which we are solving in today's video. So first of all, we understand the concept of the question, then we'll be start to solving it. So first of all, there are two cases are in today's video, okay, in today's LeetCode camp solving video. And now let's start the question. First of all, let's understand the question, and question is only for one line, okay, one line question is it. Let me show you here. You can see there is one line of question. Now let's try to solve this question. Now it has been giving me a one root of a binary tree, like this type of one root of a binary tree, like you are seeing in this diagram, okay. And what we want to do with this root of a binary tree, we want to return the leftmost value in the last row of tree. Means that we return the leftmost value in the last row of a tree, and leftmost value is in this diagram is 1, so there is output coming 1. So why? Let me show you now. Here you create a diagram in which he wrote in down 2, 3 and 1. So 1 should be left side, okay, and this has been in the right, 3 has been onto the right side. So and then the 2 has been in the top, okay. So and we want to print the left side of a left side value. Why? Because the question is trying to say we want to return the leftmost value in the last row of a tree. So in our last row of a tree, if you see here, there is a last is 1. So and it is should be in the left. So that's why here output has been coming 1. Here you got one binary. Here you get one root integer array in which he wrote it down 2, 1, 3, and the output has been coming 1 because here we print our leftmost value, okay. Leftmost value in the last row of a tree. Here you can see it. So in the diagram 2, you see there same example, so the output will become 7. Why? Because if you see here, if you let me make, so this is 1 till 2, and this is, let me make it one more time, and this is 1 till 3, okay. So this is 2, and now this 2 has been going into the 4, okay, and then this 4 has, then there is coming 3, then it is going to the 6, and then this is also be a 6. It is also going to the 5, in the last this is going into the 7. So now what is I doing here? Now let me tell you, here is like 1, 2, 3. So leftmost, you are thinking the leftmost value is 2. No, 2 is not in the last row, okay. 2 is not in the last row. It has been in the third last row. If you see here, there is a third last row 2 in the leftmost, but the 2 will be not come because it is not in the last row, and if in this binary tree. If you see there 4, then 4 is coming. So why the leftmost value is 4? Why the output has become 7? Because 4 has been also be not, because 4 is also not our last binary tree, okay. And that's 5. If you see here 5, now 5 has been coming, 5 is not, 5 is also not an in the last row, okay. 4 and 5, okay. 4 and 5 and 6, no, 6 is in the right, okay, but 4 and 5 has been in the left, so that's why the 4 and 5 has been not, sorry, 4 has been in the last, so that's why 4 has been not coming, because 5 is in the center or in the bottom if you see. Okay, the 4 will be no output, 4 will be not come because it is not in the last row, it is in the second last row. Okay, then if you come down, so in the last row there is 7. If you see here in the last row there is 7, so there, that's, and 7 is the leftmost value, so that's why the output has been coming 7. Okay, here you can see it. And if you see here, here when enter either array by the name of root, in which he wrote in now 1 2 3 4 null, 5 6 null and 7. Okay, and 7 in the 7 is in the last one, and last one, and it is also one left last value. Okay, so that's why the output is becoming 7 here. So we want, in our example, whenever we want to print output 1, in our case 2 we want to print output 7. So I hope you understand till here. So now let's start to solve our let's see our constraints which we use to solve this question. These are the constraints which it has been given me, so you will be use these constraints to solve this question. Okay, so now the number of nodes in the tree in this range and like 1, 10. Okay, now let's start to solve this question anyways. So let's come on it here, and now let's start to solve it. Okay, so now find the left bottom tree. So now what we want to do here, first of all, let me pick it and let's start to write about all the code. So now here we define here, first of all, class of a solution, and now why you are thinking why I'm defining a class of a solution, because I'm defining a class of a solution because it's a rule of a LeetCode camp. Whenever you start to solve any question of a LeetCode camp, so first of all you define a class of a solution. So define here tab keyword, find bottom left value, self comma then root. Why I'm writing root here, because it has been said me there is one root binary tree, optional tree node int. Okay, because we are convert this into the integer. Write here q equals to dq, defining here root. Now define here leftmost value. I'm defining a leftmost value because we want to find the leftmost value. Then define a while loop in which you write q. Okay, define a semicolon, enter. Define node equals to q one more time, dot pop left. So you are thinking why I'm defining a pop left. So like all the people know, pop means it will be remove everything from your Python file. So everything, not your in your queue there is all the thing has been removed from the left. Okay, from your queue, enter. Now when you define this all the things, so now you only want to do it, enter. Define a left most value equals to node.val. So I'm defining here val. Okay, and then back and then press enter. Define if statement node.write q.append. Like all the people know what is the meaning of append. It merge two things together, means q and node.write will be merged together. Okay, if node.left, enter. Okay, now when we do this, so remove these and now remove these also. Okay, define here q dot append node dot left, and then return here output, return leftmost value. Here we return our output. So now, okay, let's do this. Here we write return leftmost value and give the space from here. Okay, let's do this. Okay, now perfect. Now let's see the running code. Now we write it about all the code, and we have one question by the name of tree, depth first search, breadth first search, and binary tree. So let's run the code and let's see the output. So when I run this code, so it is taking a little bit loading. So the running code has been perfect. Error accepted. Our case 1 has been also be accepted. Our case 2 is also be accepted. If you see here. So I hope you enjoy this video. But let's see the submission code. The submission code is correct or not. So when I submit this code, the submission code is also be correct, and we beat 18% people, and I solved in 7 milliseconds. So I hope you enjoyed this video. If you enjoy, so like, share, subscribe, and don't forget to all the notification bell also, so I will these type of videos on this LeetCode camp channel. So for today, goodbye.